Okay, I'm going to um, do the recording on related to meta-analysis. And I'm going to use the Plavix research question to go through the procedures with the meta-analysis. So if you know that FDA drug safety communication stated that reduced effectiveness of Plavix in patients who are poor metabolizers of the drug. For those patients, this was issued in 2010, and the drug was manufactured in 1997. And the black box warning added in 2010 basically stated that warn about reduced effectiveness in patients who are poor metabolizers of Plavix. Poor metabolizers do not effectively convert Plavix to its active form in the body. As we know, Plavix is a prodrug, and it has to be converted by the liver enzyme and to convert it to an active form to take its drug effect, to have its drug effect anti-platelets aggregation. Therefore, it's considered as a drug not beneficial for patients who post-MI and some procedures like a PCI, and also used to prevent heart attack and a stroke. So this basically continue on inform healthcare professionals that the tests are available. Basically is a genetic testing to identify genetic difference in CYP2C19 function, and advise healthcare professionals to consider use of other anti-platelet medication for alternative drug strategies for Plavix in patients identified as a poor metabolizer. Here goes on with the Plavix has less effect on platelets if those who identified as a poor metabolizer, and therefore less ability to prevent heart attack, stroke, and cardiovascular death. It is estimated that 2 to 14% of the population are poor metabolizers. I want you to remember these numbers, 2 to 14. The rate varies based on racial background. So the questions came up because there are certain population, there are more poor metabolizers in other specific population. And so we need to find out what will be the better strategies. We're going to go over some, this is going to be a long series of questions we have to answer. Is genetic testing will, a few questions, genetic testing will be the problem solver here. And so what population has the highest percentage of poor metabolizer? Are those evidence-based practice? Because we are on the lecture on evidence-based practice. So my focus here is searching for the evidence will be the focus. So CYP2C19 has a genotype and a phenotype. We're going to go over those. And those who missing identified as a poor metabolizer, basically the ability to convert the prodrug to its active form is decreasing. Loss of function, anemia, status in CYP2C219 is more prevalent in people with Asian and Pacific Islanders ancestry. So FDA in 2010 basically issued this statement was because Hawaii, the state of Hawaii, as you are aware, there are probably about 50% of the population or even more have those who have Asian and Pacific Islanders ancestry. And in 2010, what basically brought to FDA attention is that there are more people appear to be poor metabolizers. Therefore, it was claimed that it's certainly has less benefit for this population. Strategies need to be considered to prevent heart attack, stroke. And if we thinking about it, we have the question, right? The question will be, population, the PICO question. The population will be people with Asian Pacific Islanders ancestry, right? Intervention with those who take Plavix. I think I have some point to have a PICO question. Okay, so those who take Plavix, C will be comparing with those who also take Plavix, but it's not having Asian and Pacific Islanders ancestry. And the O will be the outcome. Do they have more cardiac event? Therefore, the drug is not effective. So if you're searching for evidence, the first thing you want to know is what kind of literature you want to do a search on. You certainly don't want to do these case study, case series or case studies. Those are stories. They're at the beginning. They notice something. And of course, experimental studies like a non-randomized or randomized clinical trial, right? But if you have clinical appraisal literature or systemic review or meta-analysis, then those are critical appraisal level of evidence, and they have a highest evidence. So you want to see, first the question is there or are there meta-analysis studies or report out there? So we're going to go over more questions on these by searching for few meta-analysis based on different population. I went through the Cochrane library, and which is a library, is a database of a systemic review and meta-analysis, which summarize and interpret the result of medical research information connected from Embase, PubMed, ICTRP, and CT, the clinicaltrial.gov. And I use the keywords here. I don't want to just jump into just Asian, but the chances are, if you look for CYP2C19, it's and clopidogrel, that's Plavix. This combination, more likely, the research will be focused on genetic testing and the genetic makeup. And the third search word is cardiac disease. There are 16 clinical trials reported since 2008 to 2022. As I said, that the FDA issued a black box warning is in 2010. So it covered those periods. With these 16 clinical trials, 0 Cochrane reviews, 0 Cochrane protocols, 0, 0, 0, 0. Right. But there are 16 here reported. How many of these trials were published and or used in the data analysis? We're going to review the first one, which is from it's in the database, which is published, the rest not published. If you think about any publications, clinical trials, when they have a positive outcome, which means researchers predict this will be the outcome, and they find out this is the outcome they were looking for, then they publish that. When it's negative, then why publish it, right? So there's a publisher bias to begin with here. But one of them published. So when I further on went into Cochrane review, because I realized with the 6 clinical trials, I went to PubMed. This is a PubMed review. So I changed the words a little bit to narrow down the studies. So I used the CPY2C19, clopidogrel, heart instead of cardiac disease. Usually in the abstract or in the content, they will have a heart. And allele to narrow the study related to genetic alleles. Here we got from the same period of time, I used the same period of time, and have 130 results, publications in PubMed. And I add filters to meta-analysis and yield 6 results. And one of them is duplicate, so therefore only 5 results. One of them reported was not significant. The one of them reported was significant. And I'm going to change this one to PubMed. So we're going to go over one of the articles here and to see the results of meta-analysis. As I said, this is listed with the Cochrane, and it's the only meta-analysis published from that clinical trial. The rest are not. But there are other 5 meta-analysis we're going to review as well. But I want to review this one first. I want to make sure that my screen changed. Okay, so this one have not yet changed. I'm going to change the screen here. Okay, so this was published in 2017. Platelets. The reason I think this one was not having any review from the Cochrane review website is because the clinical trial we knew was not the first, was not the first author. So maybe they not get indexed the incorrect way. But anyway, regardless, CYP2C19 genotype and adverse cardiovascular outcomes after stent implantation in clopidogrel treated Asian population. It's a systemic review. If you remember, the pyramid of the evidence, the strongest way is a systemic review and meta-analysis. And this is by Department of Cardiology, Beijing, and then hospital. So that's most of the population. And here they used is Asian population. The study, they used the keywords Asian, clopidogrel, coronary artery disease, CYP2C19, and the genetic. If you recall, it's just information here. Usually after the stent implementation, depending on what kind of stent, if it's metal or just a mesh, they require, we call it dual antiplatelet therapy, which is DAPT, adapter. So those are the patient based on recommendation. They are going to benefit from antiplatelets to prevent a stroke or prevent a heart attack and even stroke. And this is when we talked about the evidence, they use the protocol PRISM to look for the relevant articles. And so the effect of, based on what they stated here, that the effect of CYP2C19 gene polymorphism on clinical outcome patient with the coronary artery disease treated with clopidogrel remain controversial. We are going to have a few, we're going to see the meta-analysis. Ethnicity, remember we talked about the Hawaii population. Ethnicity has been proposed to influence clopidogrel response following stent implementation in CAD patient, coronary artery disease patients with different CYP2C19 genotypes. Furthermore, Asian population are reported to have a relatively greater prevalence of a CYP2C19 loss of function annals. We aimed, the authors aimed to evaluate the impact of CYP2C19 gene polymorphism on clinical outcome in Asian population who underwent percutaneous coronary interventions, PCR, and received clopidogrel therapy. We conducted a comprehensive research in PubMed. If you recall, that's what we talked about. You have to search a few databases, Embase and Cochrane, the library, from their inception to January 2017. So this study is published in 17. Studies that reported clopidogrel therapy informations, clinically relevant outcomes, adverse cardiovascular event, stent thrombosis, and bleeding. All this related to the Plavix. Those are related to anti-platelets function, and bleeding due to its over function, right? So that's it's one of the side effects of using Plavix. And the CYP2C19 genotypes among Asian population were included. So they took only those who has Asian background. The primary endpoint was a major adverse cardiovascular event, short for MACE, defined as a composite of cardiovascular death and myocardial infarction. The safety endpoint was any kind of bleeding. That's a safety issue, right? We retrieved 20, if you remember the PRISM steps, we retrieved 20 studies of 15 1,056 patients reporting 1301 cardiovascular event. The primary analysis showed at least one CYP2C19 loss of function allele 2 or 3. It's used asterisk in the genetic reporting. One asterisk one considers normal. If they have a 2, is loss of function. 3 is also loss of function. Carriers were at an increased risk of MACE compared with non-carrier. So here is 10.58% versus 6.07%. The odds ratio here is 1.99 and 95 percentile confidence interval from the 1.64 to 2.42, and the P is less than 0.001. We're going to go over the research on that. Stent thrombosis was also more frequent in loss of function and AL carriers. That's clearly, it's one of the reasons that because antiplatelet effect is decreased due to this loss of function. ALs exist, therefore cannot convert platelet to its active form. Subgroup analysis was performed to assess difference by higher 600 milligram Plavix dose or routine 300 dose, noting those of clopidogrel and by different nationalities. The risk of MACE in loss of function allele carriers remain significantly higher, even in high loading dose group. We're going to go through these. Subgroup analysis between 3 nationalities of China, Korea, and Japan demonstrate that the risk of MACE among Chinese loss of function allele carriers was the greatest. The odds ratio is 2.28. In conclusion, among Asian population with the CAD undergoing stent implementation, this is specifically their population. Remember, go back to our PICO questions. CYP2C19 loss of function allele carriers are at a greater risk of adverse cardiovascular event and a lower risk of bleeding because they did not become active form. Therefore, they don't have the same amount of antiplatelet function. Therefore, they have less bleeding compared with the non-carriers. Genetic testing may be helpful for clinicians to personalize antiplatelet therapy, especially in Asia population. This is the abstract. I'm going to go over a little bit on their strategy here, and I hope you use the same strategies when you did your literature review. And it's always search the highest level of evidence. So here, this is how they search, their search strategy. So our meta-analysis adhered to the Moore's statement for reporting on systemic review. We conducted a comprehensive search on PubMed and Base and the Cochrane Library from their inception, January 20th, 2017, to identify studies that describe the relationship between polymorphism of the CYP2C19 gene and a clinical outcome patient with the ischemic coronary disease receiving clopidogrel among Asian population. It's very good statement to hear. That's their PICO question, right? But they used the meta-analysis. We queried MASH and the article text for the following 4 search terms: drug name, including the generic names, clopidogrel, and trade name, Plavix or clopilot. the gene including CYP2C19 or P450-2C19. They are the same thing. The patient including coronary artery disease, percutaneous coronary intervention, or drug-eluting stent, and the ethnicity including Asian, Chinese, Korean, Japanese to identify relevant studies. So this is their search term were combined using the Boolean operator and. So this is and there was no language restriction. So they give you clear statement how they did the search. So I'm not going to go into all of these. The chart is pretty speak for itself. So they identified the 276 citations and the 217 citation excluded by screening for title and abstract. It's not relevant to this purpose of the study or to answer the PICO question. 59 full text articles assessed for eligibility to answer the PICO question. Again, 37 excluded. Take a look of what if they don't have a genotype data, then it will not answer the question, right? So 37 exclude, remaining 24 articles. And the 2 study excluded for data was from the same cohort and already included. So here is missing 2. The author never mentioned why there was 2 more, unless these 2 were duplicates. So 20 studies included in the meta-analysis. I'm going to go over when you publish the meta-analysis, you need to tell the audience how or what are all the articles or what are all the researchers, the research you utilized here in your data. So you can see here, I counted it's 20 of them. And these are sorted, appear to be by year. And then the country, they have China, Japan, and Korean. And the sample size here, the age, male, diagnosis, or have cardiac issues. And then loading those, most of them are 300. There are 600 here, right? And the follow-up is a 6 month, 36 month, 12 month. You can see that, right? And the efficacies, they endpoint basically is MI-ST elevated, MI, CV, cardiovascular death, stroke, MACE. We talked about this. So those are the endpoints. And the safety, the concerns of bleeding. We talked about not all studies reported. Yeah, it's not reported. So Aeneas studied here is they have, remember we stated 2, 3, 2, those are, and they're asterisk 2 or 3. They are not function, they are non-function, lower function. So it's basically enable the enzymes of these people. If they have a 2 and a 3, that they are poor metabolizers. And the 17, ironically, I looked at these 3 population. 1 is in Korea, 2 is in China. They actually have a 17. 17 is considered as a high function. And 2, 3, 2, 3, 2, 3 again. So these are the NOS is Newcastle Ottawa scale, basically tell you how good is the study. These are pretty decent study, has its own validity. So that's what the score here means. If you see somebody have 4, 3 of these or 2, 1, Newcastle Ottawa scale, then it's concerning, right? So those are the studies they included in 12 studies. sorry, 20 studies. I'm going to rotate back the screen here. And if you see here, this is very important for you to read meta-analysis. When you read a meta-analysis, you want to see the studies included here. I'm going to pause this. Okay, so if you take a look over 20 studies, they actually give you the reference, each study, Lu in 2011, 2012, this is all the study they cited. There are 20 studies here. And this give you the loss of function carrier, which is asterisk 2, asterisk 3, and or. And the 800, in this study, 802 participants have 115 events. With a non-carrier, you can see that is 936 participants, 67 event. You can clearly see the one have a loss of function has more event, right? And odds ratio here is 2.17. And they really don't need to say publish year since that's already repeated to 95th percentile. So this is a very typical meta-analysis, how it is reported. And with the odds ratio, it's one, the line of effect is right here. It's at 1. And you can see the first one is 2.17. And with 95th percentile, each end did not touch of a line of non-effect, right? Line of effect. And this second study is not significant because it touched the line of effect, right? This one is good, although it has a big range of not cover the 95th percentile confidence interval. This one is good. This one is, again, it's actually on the other side, so that's not a positive finding towards what we want to study, right? What do they want to study? This one also not good because it touch the line of effect. This one's good, this one's good, this one's good, this one no good, no good, 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 no good, no good, no good, good. So if you, I'm going to enlarge this one a little bit to see if we get, get a little bit better view of this. So you see the dot here. If the dot is very small, the effect size is small. The dot bigger, the effect, this one is really not that. This one clearly is very small, right? And smaller than these. So the effect size, you also can see the effect size is also can be related to the participants, right? The large amount of participants dot is a little bit high, like this one, 10, 11, 11:35. But again, this one is no good because it crossed line of effect. So at the end, this report how many total in the loss of function group, how many total is no loss of function and they are carriers. And it's 6,000, and this is 8,000. And the event, you can see here, we call this one is in diamond shape. This one is called a pooled effect, P-O-O-L-E-D. Pooled effect means a summary. So compare with all these, the summary is very good. It's on the right side of the line of effect, and it did not touch the line of effect, means it's significantly to support what you try to study. So basically how to interpret this one, is the CYP 102 CYP 2C19 loss of function, ANEAS, and a major adverse cardiac event for Asian population. For those who has loss of function, 1.99, almost 2 times more than those who are the normal carrier. When they use the same drug, they have 2 times risk to have a MACE, right? That's how you interpret. If you see here, because it's a meta-analysis, it come up with the first one because this is when they want to see it first. And you see a heterogeneity. It's a tau square and a chi-square. And usually we read the I square. If I square is like 90%, 100% is not good. If it's a 47%, we call it moderate heterogeneity, meaning you are comparing with very similar studies, right? If your heterogeneity is so high, that means you're comparing so many things different within all your studies. So this one is decent. So this is a good finding. And the next one is it's association between 102 CYP2C19. This is basically we're going to just go over one more forest plot here and read it to see how significant the rest. You can look up the article and read it, okay? So association between 102 CYP2C19 loss of function, ANEAS, and a major adverse cardiovascular event for Asian patient treated with clopidogrel. And they took out this patient study less than 200 subjects. So you can see the number come down a little bit. Let's take a look to see if that really changed anything. So you still see this one is not good, but the effect size is pretty big, right? You can see the square is bigger, and this are good. This one is not good. This one is good again. It's not good, not good, 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 not good, not good, and good, not good. And here the board summary of all these studies greater than 200 patients. In the study, it is 1.8. Remember that one was 1.9. So this almost take you to a little bit different direction. You hope taking as your sample size increase, you will see what you want to study will support more of your first analysis. But I spotted that one right away is not going to help set up the argument because those who has more samples, like this one, 11, 35, 10, 11, 13, 16, those, they are cross the line of effect, right? So these are not going to beneficial to them, but that's their decision to take the 200 out. But again, it's still significantly relevant. It's significant because the diamond never touched line of effect, and it's on the high risk of event size, and it's 1.8 and here. And the heterogeneity is 23%. Is that good? Yes, it's better than 47, right? If you see somebody have a heterogeneity is a 0, that's even better. So I don't think I'm going to read all these forest plot for you. but I want to get to the conclusion. And if you recall the conclusion, so they did the bleeding, the safety, if you recall, all the all the, oh, this one is good. I want to cover it because the diamond is clearly very big, right? So what they basically say here is association between 102 CYP to C19 loss of function, which is here, and layers, and stent thrombosis. Thrombosis is, you can consider that can be the cause of a heart attack, right? The MACE event. So here, same population, and you see the thrombosis with the forest plot here, and this the first study is the effect size is pretty big and it's significant. Big, not big, but significant. Big, small, but non-significant. Pretty big, significant. Not big, but not significant. Not significant. Not significant. So in summary, the pooled effect is how you read this one. Is those who has lower function carrier of CYP to C19, sorry, loss of function layers, and will have 4.77 times high risk to develop stent thrombosis for Asian patient treated with edible. What is the heterogeneity? Wow, that's good. Okay, so that's how you read it. I hope this helps you some with the meta-analysis, develop your interest in reading the research and looking into what they're talking about. So let's see if we are finishing reading the entire article, and what is your conclusion? In conclusion, among Asian patients undergoing PCI and receiving small category therapy, carriers of CYP to C19 loss of function areas are at markedly increased risk of adverse cardiovascular event and stent thrombosis comparing with those non-carriers, while bleeding risk is lower. We did not go that chart. I'm sure the forest plot will be, if you read it, supported. The strategy, okay, this is how to inform the practice. This is why you do research, to search for evidence. As a nurse practitioner, you want to say, what am I going to do? Am I going to order genetic testing for an Asian patient? See the strategy here, the research said this way. The strategy of a higher loading dose category cannot improve clinical outcomes of CYP to C19 loss of function and there's carriers in Asian population. So that's, they have another forest plot. The high dose did not make a significant difference. The reason it's easy to deduct from that because they don't have the enzyme, therefore they cannot really convert it to active form as expected. Second, genetic testing for CYP to C19 variant, ASTRA2, ASTRA2, ASTRA3 may allow clinicians to personalize the antiplatelet therapy, especially in Asian population. This was published in 2017 based on meta-analysis. I hope this is helpful for you. And if you have any questions, please let me know. Thank you so much.